Hello everyone, my name is Devashish and I welcome you all to this video. So last week I have uploaded a very short video on my channel where I have shown I have built a ESP32 based cloud control plant watering system. So in this video I'm going to quickly show you how you can program your ESP32 microcontroller to build that on your own. So even if you do not have any other prior experience with electronics, I will try to explain the entire thing in a way that it should not be a problem for you to build it on your own. Okay, so before I jump into the programming part and the electronics part, I'll explain the overall concept, how it is going to work. Okay, so to be able to build this, you will need this particular microcontroller. As you can see, it's a very small one. Okay, it is called ESP32. Okay, so you will need this ESP32 microcontroller. Okay, and this chip has I bought it for 500 INR from Amazon.com, but if you buy it from any electronics market, you may get it at much cheaper price. Okay, this chip has built-in Wi-Fi. Okay, so this microcontroller is capable of connecting to any Wi-Fi hotspot of your choice. Okay, so let's say this is the Wi-Fi hotspot at your home. So the concept is we want to control certain pin of this ESP32, okay, from the internet, right, or you can say from cloud. So we are going to use Arduino Cloud for that. So what you have to do is you have to program this microcontroller. So how you are going to program this microcontroller? So you need a PC for that. Okay, so you need to connect your ESP32, okay, using USB. You should be able to see it has a micro USB port as well. Okay, you need to connect your PC with your ESP32, and you have to write a code in embedded C, okay, on your PC, and you have to push that code to ESP32 microcontroller. Okay, the code should have the details of your Wi-Fi, like the hotspot name, credential, etc., so that when you push the code, it should be capable of connecting to this Wi-Fi hotspot, and eventually it should be able to connect to the Arduino cloud as well. And from this cloud, we will be able to control certain functionality, or you can say certain pin of this ESP32. So for this particular example or use case, you can say, since it's a very simple one, right, you just need to control one pin. Okay, when I say one pin, so basically you should be able to send a boolean signal from the cloud. It's either on or off, okay, to a pin. Okay, so in this particular case, we are going to choose the D5 pin. Okay, D5 pin, which we are going to control. So on the chip itself, you should be able to see all the pins. So we are going to control the D5. So from the cloud, we should be capable of turning the D5 pin on or off. Okay, and that will eventually control our electronics components of the entire system. Okay, so this is the overall concept. Now usually to be able to program ESP32, you need Arduino IDE, but now you do not really need it, so you can program directly from the Arduino Cloud website, okay, or web application. So that I'll eventually show how it is done. And now the obvious question is how a web application can control a ESP32 over USB. So that's why you need the Arduino Cloud agent to be installed on your PC. Okay, when you install it and open the Arduino Cloud web interface on your browser like Chrome or Firefox, this should be your PC, or you can say that your browser should be able to interact with the ESP32 connected over USB. Okay, that I'm going to show how to do. So stay tuned. Okay, so let's get started. So first thing you have to do is you have to visit Arduino Cloud. So if you just Google it, the first link that you can find is the cloud.arduino.cc. Okay, so you can click on get started for free, and you need to log into your Arduino Cloud portal to be able to access all the features. Okay, so as I said, you need Arduino Cloud agent so that your browser can interact with this particular chip when you connect it over USB. So I also have a micro USB attached to my system that you are seeing, okay, that I'm going to eventually connect. Okay, so as you can see, it is trying to load an agent, and I think I already have the agent running here, as you can see on your task pane. Now the first thing that you have to do is you have to go to this devices. Okay, and first you have to add your device. So now Arduino, to be able to use Arduino Cloud, you do not necessarily need a Arduino device. Okay, you can use any third-party device like the one that I'm using, which is ESP32. So what I'm going to do is I'm going to click on third-party device. I'm going to select ESP32, and I'll have to choose the model that I'm using. So when I bought it from Amazon, what I could see is the model that I'm using is this one, ESP32WRMM DA module. Okay, I'll click on continue. I'll just name it as Dev ESP32 and click on next. Now this is important. So when I add my device here, so it is going to generate a device ID and secret. So what are these secrets? Okay, so now let me open the diagram that I was drawing here. Okay, so this secret and the device ID will help the Arduino Cloud to distinguish. Okay, so this is the unique device that is being connected to the cloud, so it is basically the unique identifier of your device. Okay, so when you push the code, your code will have these devices and secret code embedded into the code. Okay, so that I'll show where it is being done. But this is how basically Arduino Cloud uniquely identify this is the ESP32 that I own. Okay, because you can understand there can be billions of IoT devices connected to Arduino Cloud. So how the cloud actually identify? So yeah, now I'll download the PDF. Okay, because I'll later need this device ID and secret. I'll say I saved my device ID and secret and click on continue. Okay, done. Now the next thing that I have to do is I'll go back to devices and go to things. Okay, I'll click on create thing. So this is basically we are initiating our project. Okay, and now I'll click on cloud variable. So I'll click on my LED variable. So basically I said that I'll be controlling the D5 pin of this particular ESP32. So first I'll connect an LED to my ESP32. Okay, so that's why I'm naming it as my LED variable. So I'll call it my LED var, and for this very basic thing we need a boolean. Okay, so I'll just choose my boolean because it's just either on or off, so I'll let it be default. Read write means we should be able to change it. Okay, that's why it's right. Read and write both we are taking. And variable update policy on change, because it is similar to event listener, as you can say, whenever certain change happen, it should be able to trigger it. Okay, I'll click on add variable. The next thing that I have to do is I'll associate a device. Okay, so as I have added this device Dev ESP32, I'll associate with this one. And the next thing what I'm going to do is I'm going to configure. So this is the hotspot and password of my Wi-Fi that this device will be using. So my Wi-Fi name is Debashish and password is okay. And the secret key, whatever I have downloaded. Okay, so I'll be using this secret and paste it here. Okay, and save it. And I'll just rename it water project. Now I'll go back. I'll go to dashboard. So what is dashboard? So dashboard is basically, you can say, the mobile app, okay, using which or you can say the user interface through which you should be able to control a pin. Okay, so you can do it later as well, but I thought of doing it right now so that I can show. I'll click on create dashboard. Okay, and this dashboard is water my plant. rename. I'll click on edit. We'll just need a one switch here, right, on or off. I'll link a variable. So if you remember, I have created my LED variable. I'll link it, okay, and I'll click on done. Okay, done. I'll go back to dashboard. Now I'll go back to things, and this is our project that I have created a few minutes back. Okay, now we'll have to go to sketch. So sketch basically will allow you to program the device. Okay, this is the default code that is there. Okay, so first thing what you can do is first connect your ESP32 to your system. So just to test if the connectivity is fine and the device is working okay, so I'll just connect it. So as you can see, there's a light, okay, which means the connection is successful. Now we'll try to push this code to this particular device. This is not the code which will help us build the project, but this is just for testing purpose. So what I'm going to do is I'm going to click on upload. So as you can see, it is verifying, and eventually you will see that it is doing some compilation, and eventually it will push it to this particular microcontroller. Usually it takes some time. And one more thing is there is a serial monitor through which you should be able to see certain operation that is happening on your device itself. So that all the debug logs and stuff that you put in your code. So as you can see, the console is verifying it's 44%. Now the compilation is done. Now it is going to push the code, or you can say write the code to this chip. So as you can see, it is connected to COM5, and now it is writing the code, okay, here. So which means the chip is working fine. You are able to push your embedded C code into this, and the connectivity is also absolutely fine. Okay, now what you have to do is you have to write the code so that we can control the D5 pin, okay, of our device. So for this I need to connect an LED as well. So what I'll do is I'll connect this to this breadboard. Okay, I'll just connect it, to this breadboard. Just press it. Now it is fixed here. Okay, now we'll update the code, okay, here. So this is the code that I have only written, but I'll just copy paste so that the video length is smaller. So I'll quickly explain what we are doing here. So basically we want to control the D5, okay, that's why we are creating we're defining the LED pin 5, okay, since we want to control it. And these are some of the default code that comes in, okay. In the initial code that I have shown, it was still present. The only thing that you have to change is you have to under the setup function, you have to set this pin mode, LED pin, comma output. So you can just copy paste it, and after that you have to come back to this one, okay, the loop function. This is also the default function, will always be there. It is basically, you can say, it will run this particular function in a loop, okay, continuously it will keep on running. So basically it is trying to fetch the status of the variable that we have defined, okay, from the cloud, okay, Arduino cloud.update. So it will connect to the Wi-Fi and it will check the variable status. And this is kind of, you can say, the event listener, okay, and that will set the, depending on the cloud variable, it will set the value, okay. So this is the function digital write LED pin, my LED var is the variable that we have defined, okay, and depending on the status of the cloud variable, it will eventually set it. Now where is the username and password, Wi-Fi username password, okay. So these are some of the secrets that are actually stored here. So when you compile this code, these secrets will be embedded into this code. So for the ease of use, the Arduino Cloud does that in this way. However, it is actually when you compile it, these secrets will eventually be embedded into your code. Okay. Okay, so think properties, as you can see here also, the secrets are actually embedded. As you can see, this is the device ID. When we open the PDF that you have downloaded, you should be able to see this is the same device ID. Okay, and this is the secret SSID, your Wi-Fi SSID and password, and this is your device secret, which will help the Arduino Cloud identify that it is dealing with this particular system that I own. Okay, now what we can do is, my LED var is the variable name. I'll just verify once again that I am using the correct variable name, my LED var. So I'll just go to things and go here. This is my LED var. Okay, so we are good here. So now what I'm going to do is I'm going to hit this button. Now it will compile the code, and since it is now connected, it will push it to this particular microcontroller that it is connected. Now when it push this code, what we have to do is we'll have to set up the LED so that we know that we are able to control the D5 pin. Okay, so here are certain things. So for LED, if you do not have prior understanding about LEDs, so the smaller leg of an LED is the cathode. Okay, so that will be put to the ground. Okay, so what I'm going to do is the longer one I'll put on D5. Okay, and the other one I'll put in ground, and on your ESP32 there is a ground pin as well, so I'll connect the cathode of LED to the ground. Okay, so this is now connected, and meanwhile what we can see, the code also is now successfully connected, is pushed to my code. Now I'll open the serial monitor. Just refresh it. For some reason it is, I think it is not free yet, the serial monitor. Okay, now I'll go to serial monitor. Here you should be able to see that my ESP32 is connecting to my hotspot. Okay, as you can see, initially the connection was failed. However, now it is connected to my hotspot. Okay, it's connected to the Debashish, and now as you can see, this is the thing ID, which means now we should be able to control this LED that you are able to see. Now we'll go to things, dashboard is the one that we created with one switch, right? So now this is off, right? Now I'll turn it on. As you can see, the moment I turn it on, you should be able to see the LED is turned on. So usually it is not recommended to connect the LED directly. You need to use a register so that your LED is not burnt. But but just for the sake of showing you, I'm directly connected. I have directly connected the LED to ESP32 D5 pin. So as you can see, when I turning it off, the LED is turned off, and when I'm turning it on, the LED is on back on. So now you can use this dashboard on your phone, and from anywhere in the world you should be able to connect it. You should be able to control this LED. Now right now this particular ESP32 is connected to my PC. However, you can, since the program has already been transferred here, you can connect it to any power bank or anything. Still you should be able to control it. Okay, so the next thing that I'm going to show you is the electronics component part. How you can actually using the D5 pin, you can control a relay and eventually trigger a 5-volt motor so that you can water your plant. Stay tuned. So welcome back everyone. Now in this part of this video I'm going to show you the electronics component you need to build this project. So as you can see right now we have the ESP32 programmed ESP32 microcontroller placed in the breadboard, and it is the LED that we are able to control from Arduino Cloud, and as you can see, if I turn it off, it is going it is we are able to control this LED basically using the D5 pin. Okay, now as you can see, there is no external connection to this particular system. It is just connected to an external power source, which is the power bank that I am using. Okay, now we'll need a 5-volt relay which will using which we'll be able to control the 5-volt pump that I have bought from Amazon. So I think I bought both the things for around 250 rupees, but if you buy it from electronics market, you will get it at much cheaper price. Okay, this will come around 45-50 rupees, and this will also be around something similar. Okay, so now what we are going to do is we are going to remove this LED and connect the relay. Okay, so I'll remove it and I'll turn it off as well. Okay, so now there's certain way you connect a relay to your ESP32. So basically there are 3 pins. One is in, GND and VCC. So the VCC pin you should be able to you should be connecting it to the 3-volt 3V of your ESP32. After that the ground should be connected to the ground. So I'm connecting it to the ground. As you can see, the moment I connected it, the ground, the red light is on, and the in switch, okay, is the actual the control switch which is the D5 pin of our ESP32. So the moment I connect it, I'm not sure if you are able to hear the sound of the relay. So if I turn it off again, you should be able to hear the sound, which means the relay is triggering. Okay, now if I turn the light off, you should be able to see this light is turning on and off. Okay, through the cloud, Arduino Cloud. Now we'll check the connectivity, conductivity. So I'll use a multimeter to show you how this D5 pin is actually controlling the circuit of the other side of the relay. Okay, so now I have placed it into the conductivity mode. As you can see, now I'll just push this to switch here. Now it is conducting. Now if I turn it off, as you can see, it has stopped, which means the circuit has broken now. Okay, now if I turn it on again, the circuit is on. Okay, so now using the same logic, we are going to control this pump that we have here. Okay, now let's remove this multimeter. Let's turn it off. Now we need an external power source for this 5-volt pump as well. That is why you should be able to see I have this another power source here. So let me build the circuit. So now I have completed the circuit. You should be able to see the moment I turn the switch on, okay, it is triggering the pump, 5-volt pump that I have. You should be able to hear the sound, right? Now if I turn it off, the pump is off. Okay, so now the concept is you can, this is a submersible 5-volt pump, so you have to put it in a bigger size water bucket, and when you are away remotely, you can turn this switch on for few seconds, so that it pumps the water from bigger bucket to the plant, and after that you can switch it off. So now to show you the final demo, what I'm gonna do is I will put some color into this bowl so that you should be able to see it is able to pump the water. Okay, I'm putting some color here. Okay, now this is a submersible 5-volt pump. Okay, So what I'm going to do is put the pump here, and this is the glass where I want to pump the water. As you can see, I am putting it here. Now if I turn the switch on, you should be able to see it is pumping the water from this bowl to this glass. I can turn it off, turn it on. Yeah, so that's how you can build your own plant watering system. Thank you so much for your time. I hope you are able to learn few things here. I'll be also attaching the circuit diagram, okay, along in the, you should be able to find the circuit diagram in the video description, so that you can build this circuit on your own. I know my camera is not very good, so that's why it is not able to zoom into the electronics component very clearly, but I'll attach the circuit diagram so that you can build this circuit on your own. So thank you so much for your time. I'll see you in the next video. Bye bye.